So question 8 then is the integration by substitution question from this paper. So we've been given the substitution u equals 4x minus 1. So I'm going to, first thing is to differentiate u with respect to x, so du by dx, which comes to 4. And what I'm looking to do, remember, with integration by substitution, is to write everything here in terms of u. So I firstly need to rearrange this to find out what dx equals. So if I multiply both sides of this by dx, I get du equals 4 lots of dx, and therefore dx is equal to du over 4. Okay, so that's going to be our first thing that we're going to substitute into this equation. So we are integrating between 1/4 and 1/2, and those are the limits in terms of x, remember. So they are the terms of x. 5 minus 2x multiplied by what is in fact u to the third. And instead of having dx here, I'm going to write du over 4. Now, at the moment, I haven't yet got everything in terms of u before I do my integration. So I'm going to try and rearrange this term, or substitute, in this term by rearranging u. So if we take u, we want to find out, what x is equal to. So u equals 4x minus 1. So u plus 1 equals 4x. So I've added the 1 over. Now just divide by the 4. So x is equal to u plus 1 all over 4. So that's what I'm going to be then substituting in here. So the second line that I'm going to write down in my main workings here are my two limits, which are still in terms of x. We are going to change those limits in a little bit. 5 minus 2 lots of u plus 1 over 4 times by u to the third times by du over 4. So everything here, so I just want to close off that second bracket there. So everything in here is being multiplied together. So let's just tidy up this term here by by cancelling down. So the 2 which is on the top and the 4 on the bottom are going to cancel down to leave me with a half. So I've got 5 minus u plus 1 over 2, and all of that is being multiplied by u to the third du over 4, and the integration is between 1/4 and 1/2. Now at this stage, I've got, within this bracket here, I've got two terms, one of which is over 2 and one of which is not a fraction. So if I rewrite the 5 as 10 over 2 minus u plus 1 over 2, and all of that is being multiplied by u to the third, because what I'm trying to do is just get a single fraction in here. There are other ways of approaching this problem, but this way ends up leaving us with something that's quite neat at the end. So 10 over 2 minus u plus 1 over 2, and that u plus 1 over 2 is all minus, yeah, it's the implied bracket on the top there. So what I'm ending up with is 10 minus u minus 1 over 2. That's what's inside that bracket there, u to the third, and we're integrating with respect to du, which is still over 4 there at the moment. So at this stage, I'm going to tidy up my bracket. I'm also, I'm just tidying up the bracket to start with. So I'm just going to scroll down and give myself a bit more room. So I'm integrating 10, not 10, it's 10 minus 1, which is 9, minus u divided by 2. That is being times by u to the third, and that is being times by du over 4. So we have got a constant of 2 times 4 as a denominator. So we've got a constant of an eighth that I'm going to take out the front of this bracket here. So I'm left with 9 minus u times by u to the third du. So expanding this one now, we are then ready to integrate. So expand that bracket, the eighth comes out the front here. I've got a quarter and a half. I'm integrating 9u to the third minus, and this is u to the 1 times u to the third, so add the powers, u to the 4/3 du. So I'm now going to do my integration. So the integration, add 1 onto the power, divide by the new power. So I'm going to have 9u to the 4/3 over 4 over 3 minus u to the 4/3, sorry, I'm adding 1 on there, u to the 7/3 over 7 over 3, and those, we've got the eighth out the front and our quarter and our half, which are still in terms of x. So first thing I want to do is tidy this up. So this is why the effectively the rule that says that if you've got one thing divided by another, that is the same as the final one being brought up to the top there. So I have 27 u to the 4/3 over 4 minus 3 u to the 7/3 over 7. Now at this stage I'm going to change the limits. So instead of having them in terms of x, I'm going to have them in terms of u. Because if I have my limits in terms of u, I can just substitute them in to the 2 points of u there. If not, I've got to substitute x back in, and I'm just making more algebra for myself and more possibilities to make a mistake. Okay, so now we're going to change our limits. So we'll recall that u is equal to 4x minus 1. So we're going to change our x is equal to a half and our x is equal to a quarter to be something in terms of u. So if, or sorry, so should I say, when x is equal to 3, when x is equal to a half, I don't know where I got 3 from, u is equal to 4 times a half minus 1. Now 4 times a half is 2, minus 1 is 1. And when x is equal to a quarter, u is equal to 4 lots of a quarter minus 1. So 4 lots of a quarter is 1, minus 1 is 0. So we've ended up going from a half and a quarter as our limits to something far nicer, 0 and 1. So let's just give ourselves a little bit more room. We're now going to copy down this line again, but this time giving our limits in terms of u. So I've got 27 u to the 4/3 over 4 minus 3 u to the 7/3 over 7 between 0 and 1. So what's nice here is that we know that we're just going to be subtracting 0. So I only need to substitute 1 back into this equation. Now we're asked for the exact value, so we're going to not just plug it into our calculator because we're going to try and make sure that we get something that's exact. So I've got an eighth of 27 times by 1 to the 4/3. Now 1 to the 4/3, 1 to the power of anything is just 1. So I've got 27 over 4 minus 3 times 1 to the 7/3. And again, 1 to the power of anything is just 1. So minus the 3/7 there. Okay, now at this stage, I can see that this is just going to be a fraction. And so I will just use my calculator. Let's just bring it into shot. We will just use the calculator to finish this one off. So it's going to be an eighth times by 27 over 4 minus 3/7. Now this then does give us our answer in exact form. It's going to be as a fraction and not as a decimal. So 177 over 224. 177 over 224, which is the final solution for this problem. Now, the solution that I've given you here is obviously one which has been sort of thought through, and there's a few steps that perhaps you're thinking I won't necessarily take. But the changing of the limits is a very important step that you do make sure that you change, because otherwise you're putting in a half and a quarter, and there's a lot more work to be done. The other step, I suppose, that was slightly out there was to, instead of expanding at this stage, we decided to find this as a common fraction. And that just means that instead of having 5u to the third and then two more terms, u over 2 times u to the third and 1 over 2 times u to the third, I'm down to 2 terms to integrate instead of 3, which just saves time. So this is possibly the most simple and fastest solution to the problem, giving us an exact value of 177 over 224.